Hey everybody, today we're going to be continuing to talk about scientific notation. And basically scientific notation is just something that we use in order to write numbers that are very large or very small. And we write them it kind of shortens them up and makes it, I guess, easier for our brains to kind of comprehend what they're talking about. And also if we don't have enough room on our paper, if it's a very, very long number, it gives us the space to do that. So later on you will be practicing moving or changing these numbers from standard form, which would just be how we normally write our numbers, just regular form, into scientific notation and back again. So you'll be doing both. You'll be switching from standard to scientific and from scientific to standard form, back and forth. And what you need to remember is in scientific notation, here's an example of a number written in scientific notation. Let's do, this is just kind of a random number that I have, 3.102 times 10 to the second power. Okay, so this number right here is written in scientific notation. And this number also has a positive exponent. So this 2 right here, okay, that is a positive exponent. So if I look up at my top up here where it says positive exponents, okay, sorry, I actually didn't know I was going to do that. It's kind of cool. Where it says positive exponents, I know that this number, when it's written in standard form, it is going to be a large number, okay, because it has a positive exponent. In comparison, if I have the number, let's do, in scientific notation, 1.75 times 10, and it will always be times 10, and let's do times 10 to the negative 3. This exponent here is negative, which again, if we look up at the top, shows us they're going to be a very small number. Okay? So when you are changing these numbers in scientific notation back to standard form, it's actually not super difficult to do. You just got to remember kind of your strategy of what you do. You just do the same steps every time. And you need to look at the exponent for your guide. Okay? That exponent will guide you. All right? So let's do a little. So just really quick, I think you'll be doing this later on in another video as well for another lesson. But just a really quick example for how to turn each of these into standard form instead of scientific notation. So let's take our 3.102. Oops. Okay, times 10 to the second, okay? So what we're going to do is our 3.102, we already know that this is a large number just because it has a positive exponent, okay? And I'm actually going to let me make my decimal point blue, just so we know where it's at. Now, what we're going to do is we're going to look at this exponent here, which we already did, and it's a 2, and since it's a positive 2, I'm going to move my decimal 2 spaces, or two numbers, to the right. Okay, so when I'm moving this, I kind of go 1, 2, so 2 places to the right. Okay, so now I look at where my new decimal is at. So if I were to write this number out, this is equal to 3. I look where my decimal is now. The decimal is not there anymore. 310. Now I have my point, my decimal point, 0.2. Okay, so I have just turned 3.102 times 10 to the second from scientific notation into standard form, which would be 310.2. Okay, so that's, in general, a larger number. It is bigger than 1. Okay, that's kind of like the main thing. It's larger than 1. So doing a similar thing with our 1.7, that's not a 7. I was getting ahead of myself there. 1.75 5 times 10 to the negative third. Let's do my blue decimal point there, and I'm also going to circle this. So now that we have a negative exponent, what I'm going to do is move my decimal point here 3 spaces to the left. Okay, if you think about like on a number line, you've got the negative numbers on the left of the number line to the left of 0, and your positive numbers to the right of 0. Kind of the same thing. If you have a negative exponent, you're going to be moving your decimal point to the left. Okay, so I'm going to move it to the left 3 spaces, 1, 2, 3, and even though there's nothing there, we're just going to kind of fill in some zeros there. So now that I've readjusted my decimal point, now I'm going to point, because it's to the left of my number now, point 0, 0, 1, 7, 5. Okay, and we can completely take out the times 10 to the negative third. Okay, we're taking that out when we move it back to standard form. Okay, so in order to change that number in standard form back to scientific notation, all you would have to do is move your decimal. So this blue decimal, you'd have to move it over until you are past your first number that is not 0. So we start with 0, 0, 1. So the first non-zero number is 1, and that's where we would move our decimal point to. Okay, which if you look back over here, when we started, it was 1.75, which would be the same over on the right again. Okay, so that's just kind of like the basic gist of when you would have a positive exponent or a negative exponent. And the whole idea for scientific notation is that it can shorten the amount of numbers that you have to write, make it easier to understand. And if this is at all confusing, just know if you get a number written in scientific notation and you're not sure what it is, let's take our 3.102 times 10 to the second. We'll take that one again. So this number, if we were to figure out what is 10 to the second, okay? What is 10 to the second? So I know that 10 times 10, which would be 10 to the second, is 100. So what we're saying is 3.102 times 100. Okay? Sorry, that is awfully sloppy. It's getting kind of difficult to write on this. Okay. So 3.102 times 100. And when you do that, you end up with, remember this answer all the way up here? There it is. That's all it is. So, yep, that's basic rundown of scientific notation. Hopefully this makes a little bit of sense. All you have to do is move your decimal, the number of spaces to the left or right, depending on what your exponent is, whether it's positive or negative, and then the number of the exponent will tell you how many spaces to move it.